Hey man, yeah. So I just sketched this real quick from that picture that you sent me, and yeah. So I can kind of walk you through this real fast. So we've got the parallel lines on the top and the bottom, and then all those angles. So I'm actually going to add a couple of angles, and I'm going to keep their angle, or I'm going to add a few angle names. Actually the only one I need to add is this one right here, and I'm just going to call it Z. And the reason that I'm going to do that is because I know that due to when two parallel lines are cut by what we call a transversal, which is going to be, I'm just going to real quick highlight it in this blue here. I'm going to look at this transversal thing right there. When two parallel lines are cut by that, we have a fact that is true about what we call alternate interior angles, which basically mean that where Z is right now, that is going to be congruent to this angle right here because they are on alternating sides of that transversal and they are on interior sides of the parallel line. So those I know to be congruent. And then I'll erase that. And then I also know what's called vertical angles. Vertical angles are angles that are just on opposite sides of two lines that intersect. So like that and that, those are vertical angles. And I know that those angles are congruent as well. So I'm going to look at a couple of the angles that I have right now. For example, B has a vertical angle right here. So this is also known as B. And C has a vertical angle right here. And what that does is that actually helps me because now I'm dealing with triangles there and there where I have C and D as a part of the triangle on the bottom, and I have A and B as a part of triangle on the top, part of a triangle on the top. So the reason that this is going to be helpful is because I know some things about triangles, right? I know that triangles, their angles add up to 180 degrees. And so I could make this statement. I could make the statement A plus B plus Z from this top triangle up here. That is equal to 180 degrees, okay? Now, I don't need to make that statement, but I'm just showing you that I can. Actually, and that will be helpful, actually. So I do need to make that statement. But the other thing I know about triangles that's going to be interesting is that I know, and I can kind of do a brief proof explanation of this real quick. I know that there's something called an exterior angle. So I'm going to look at this. I'm going to resketch that triangle that I have on the bottom with C and D in it. So D is right here, C is right here, and Z is on the outside. So this idea is that what we call remote interior angles, which are C and D, they are actually, their measures, when you add them together, are equal to the measure of angle Z, this exterior angle, okay? So we could say this, Z is equal to C plus D. And the reason that is because I know straight angles, which is this one right here with Z, those add up to 180 degrees. And I also know that the three angles of a triangle add up to 180 degrees. So that little squiggly line plus C plus D equals 180. So if I were to take that out, so basically I would say Z, you know what, I'll name this X. Let's just name that X. Z plus X is equal to 180, and D plus C plus X is equal to 180 because it's a triangle. So this one's a straight angle, this one's a triangle, both equal to 180. If they're both equal to 180, I can just substitute them out and say Z plus X is equal to D plus C plus X. And then I have an X on both sides, so when I subtract that across from both sides, they would cancel out and leave me with Z is equal to D plus C. So that is called an exterior angle. That's kind of the exterior angle postulate, and it is equal to the remote interior angles D and C. So I'm going to plot that in or just grab that information too and say Z is equal to C plus D. Okay, and then I'm going to do one more thing before I can make a huge claim here. Actually, no, I don't need to do one more thing. I can now just do some substitution. I see this Z right here and this Z right here. If Z is equal to C plus D, I could just plug in C plus D for Z up here, which actually will satisfy all four A plus B plus C plus D, like so, A plus B plus C plus D. Okay, so I just substituted that in right there, and it's all equal to 180 degrees. So that's kind of the quickest way that I've found to do it. Hopefully all of those match up with the things that they've gone over in class so far, so that they can use things like vertical angles and things like the exterior angle. But I'm hoping that I explained it enough too that even if you haven't learned it, you can still use it. So hope that helps. A plus B plus C plus D is equal to 180 degrees. All right, let me know if you need anything else. Thanks. Bye.